In the previous discussions, we learned what is the content and what is MVC and what is POSO class. Okay, so in the course content we understand, and we understand about Spring Boot Core. It's a base module, and we understand about MVC architecture. About each layer in MVC architecture, we clearly understand what is front end, what is controller, and what is business class, and what is DO class, what they do, and which modules are helping us here to implement that MVC. We understand them, and we understand for backend implementations we need to use simple POSO classes. Backend with simple POSOs, we are calling them POSOs. And in yesterday's discussion, we understand or we learned that static way of object creation and a dynamic way of object creation. How to create objects in core Java with the new keyword. We learned this as well. Using new keyword, we created objects, and we learned how to create objects using class dot for name also. Here just by giving package name dot class name dot new instance. Hey guys, go on mute if you're not on. Okay, I just muted everyone. If you want to ask any questions, right, I'll unmute you after discussion is completed. Okay, then you can speak. Between, if you want to ask anything, you can type it in chat or raise hand. Okay, I'll unmute you. Yeah. So we understand how to create object using class dot for name also. So the first approach we understand, this is a static approach, and we learned the problems also, cons. So the problems we understand when we create objects using new keyword, it will make the code tightly coupled. It will make your code tightly coupled so that changes are not so simple. When client or business want to change any code, it will be difficult, or in other words you can say we should edit the code, and then we need to recompile, then redeploy, retest, redeploy. All this we need to perform, and it may produce a lot of issues. It may produce a lot of issues also. So to overcome that problem, if you go with this class dot for name, to overcome static object issues, don't assume that the static key is like a static keyword. What I mean static way is keeping a hard coded value. Okay. So to overcome the hard coded objects using new keyword, we can use class dot for name approach with Java runtime polymorphism. Using Java runtime polymorphism, we can make application dynamic. We can make application dynamic so that the advantages easily we can remove any layer code, and we can add new code, or we can replace old code with the new code. Okay, with a new keyword we can replace easily, we can remove any layer code, which means MVC. In MVC, any layer code you can remove, and you can add new code that we understand with example. For that purpose, we are using interface and implementation approach. We are using implementation approach, interface and implementation approach to achieve that. Within, did you join? Yes. Yeah. So using this approach, we can make it dynamic. The same principle you need to follow throughout your career to make your application more dynamic. Still, the experts or experienced guys, they are not following it as I'm saying the code, right? Many, they don't care about the future enhancements, but that's not a good practice. Okay. So nowadays, particularly, right, people are asking to follow solid principles. That's a different topic. Okay. So in solid principles also, this interface aggregation will say the same thing. Interface aggregation and dependency inversion. So if you understand the yesterday topic, runtime polymorphism, that is all about this interface aggregation and dependency inversion. Okay, we can talk about solid principles later also. This is not related to sprint. But in interviews, you'll be getting question what is solid. principles. Okay, we can talk about them later. So if you can follow Spring with the solid principles, you can make a beautiful application which is easy, maintainable for future enhancements. Okay, now let's see how Spring is doing the same thing. Instead of class dot for name, right? To achieve runtime polymorphism, instead of class dot for name, Spring core module, providing IOC containers. Okay, we are talking about IOC containers now here. IOC containers. We are going to talk about IOC containers. Let's see how they will help. Now, practically, we see from the yesterday's example the benefit of class dot for name. The benefit of class dot for name. When Vasu used, or when Vasu used a new approach, new keyword approach, he was unable to change his phone and SIM card. So let me put a red line here, and let me put a green line here. So when he used class dot for name approach, easily we changed phone and SIM. Easily we changed phone and SIM. So for that purpose, what we followed, we provided interface implementation. We provided interface implementation. For phone interface, we have given two implementations: iPhone and some Redmi. You remember the example, right? Yesterday one. iPhone and Redmi implemented from phone, Geo and Airtel implemented from SIM. So in hard-coded approach without runtime polymorphism, hard-coded with no runtime polymorphism, hard-coded with no runtime polymorphism. This is dynamic with runtime polymorphism. So here we used a new keyword. Directly we created iPhone object. So and directly we created Airtel Geo object here. So also unable to change from iPhone to another phone and Geo to another SIM. Whereas in Nitin class, we loaded classes. We loaded classes during runtime. So any class we were able to load, either iPhone or Redmi or Jio or Airtel SIMs also we were able to load, and we typecasted them into parent references. We typecasted them into parent references in this Nitin user class. So we did two things there in the Nitin class. We created object firstly with a dynamic class dot for name approach, and we typecasted into parent. iPhone object we created and we kept it into phone. As per Java, it is possible. And Redmi object we created, same thing again, we kept it into phone. So that what I achieved, I can call implementation methods. Whatever method I have calling method in phone, when I call that calling method, that obviously will call the implementation class name, either iPhone or Redmi, whichever you passed. That class methods only it will call. So execution will not change, but you get the dynamic or flexibility here, like how you are using SIM cards in your phone nowadays. We can easily remove slot, and there we can place any SIM card. So such a flexibility your phone is giving. Same way your classes also should have such flexibility. So this class dot for name is giving you like a slot kind of support. So using this class dot for name, easily I can able to pass any phone or any sim, so that this class will become more dynamic. That is what we realized in yesterday's example, right? So one more time, just let me execute it, and we will continue further. Almost loading, just a minute. Yeah. So the runtime polymorphism example I'm showing you again. If you understand this, it is fine. If you don't understand it also, it's okay. Okay. But it is a simple core Java concept only. So I have a phone interface having one method here with no implementation. Sim interface having one unimplemented method. Do you have a doubt anybody why interfaces and implementations in Java? Did you guys learn why interfaces implementations are required? Maybe if you don't have depth knowledge also no issue. But interfaces always have the signature only. Like you can consider them like a plan. While before constructing a home, house, right? How we will take an engineer's plan on paper. So interfaces also nothing but the plan only. They will have don't have any implementation. But using the building plan, how we construct a right house, we will exactly follow the plan. As per plan, we will put the foundation, then pillars, then walls, concrete, paints, right? As per the engineer plan. Same way, interfaces also will have no implementation. They are nothing but a plan. And classes are like a implementations, like constructing actual home. Okay, so I have a phone interface. Just the plan is phone should have a calling feature. Okay. Now whoever implements that plan, this is a building plan, a 2 BHK building plan. Either you construct a house or me construct a house or anyone else. If they follow that plan, they must implement the plan. So iPhone is implementing it, calling. Okay. Same way, Redmi also want to build a phone. They need to follow this interface and they should implement. So finally, both are implementing calling method as per plan. Same way, SIM also our interface. It is telling that all the SIM implementations need to have connecting calls feature. Just a plan for SIM. And we have SIM implementations. Geo provided implementation. This is reality. This is a plan. This is a plan, no implementation. And this is the reality, actual implementation. And Airtel also implemented. Now, okay, why we went through plan and implementation means that is the best way. Without building plan also you can construct a home, but you don't know how finally it will be output of your home. You don't know. On the fly you will do the changes. It may go well or it may not go well. But when you have properly interfaces and implementations, it will give lot of advantages in Java. Okay. So Vasu having a direct way of object creation, so his class will become tightly coupled class. When you do direct way of object creation, it will become tightly coupled class. This is the tightly coupled class. Always this class should continue with iPhone and Geo only. In case if you want to do the changes, lot of code you need to change. As you have only two lines of code, you may think this is okay. But generally in real time, after object creation, right, we will use this reference in hundreds of places below the code. So if you touch this code, if you remove this code, or if you rename, at least, see, I renamed it, giving one line error here. The same kind of reference, if you are using in 100 places or 200 places, you will be getting error. So doing a small change itself giving a lot of errors. So after implementation, making a change will give a lot of errors. So without doing changes, how we can change the implementation? Not possible. Not possible. If you want to put Redmi here, new Redmi, if I put will it allow? No. It will say no, you can't able to typecast it. So that's why Java brought a feature that any implementation object you can put it into parent reference. Using that advantage and using the advantage of class.forName runtime object creation, what we can achieve, any implementation class name you can pass during runtime and you can typecast it into parent reference. So what is the advantage that I got here? I can pass any implementation here. So during your use case implementation, whatever use case you implement, registration page or login page, whatever it is. For that login page or registration page, when you write some classes here, controllers, services, DO classes for your use case, and implement them. Let's say I have registration form or login form. So when I have implementations here, controllers, services or business and DAOs, when you want some changes, when you want to change DAO from JDBC code to Hibernate code, advanced code I want to apply here. So it should not make unnecessary issues on other layers. When you want to do the changes here, smoothly your change should be able to apply. So when you follow interface implementation model in this all use cases, right? In future, when registration form changes, if you want to do either in DO or business or controller, it will make your changes very smooth without compilation errors and all. So the same thing I followed here. At runtime using class.forName I'm creating object and typecasting into parent reference. This is all core Java concept. Okay. So calling from Redmi, Airtel connecting to calls. And when you want to change, just do the configuration changes. Automatically it will shift your code from Redmi to iPhone. And if you want Airtel, you can continue with Airtel. Calling from iPhone with Airtel. Anything, any changes you can do. It will support you without applying changes or touching your code here. That is the beauty. That is the beauty of runtime polymorphism on class.forName. So Spring understand that and they captured that feature from core Java. Spring understand that. Or Spring team understand that. They are experts. They understand the beauty of class.forName and runtime polymorphism and they decided to create containers. They decided to create containers to make your job simple. Maybe all people may not aware of this way of coding, how to use class.forName and all this. So what they did, they created a framework. Frameworks are always given for to make developer jobs easy, to make our life easy. Frameworks came. Whoever implemented framework, Gavin King, is it Gavin King or Rod Johnson? Rod Johnson, he thought about it. Let us read about it. Johnson. Rod Johnson. He's the CEO of Spring Source. Later it went to Red Hat. He implemented a first version of Spring Framework co-founder. He written a lot of books and he author also. Okay, you can read about him. Now the Spring is from Pivotal, Red Hat. They are both maintaining it. Lot of team deployed on it, and they are continuously working on new features they're bringing into the market. So he thought about it as Java is providing this runtime polymorphism and class.forName feature. And he thought, why can't I design a framework using this feature as a baseline? So he used this class.forName and runtime polymorphism as a baseline, and he started designing a framework on top of it. He designed a framework. Initially, he named it Interface 21. Later, he changed it to Spring. Interface 21 is the initial name. Later, it changed it to Spring. Okay, and the organization he started was Spring Source. Now it is not belongs to Spring Source. Now all the Spring releases are from Pivotal company, Red Hat, together providing support. Current company who is maintaining Spring. All Spring releases are coming from this company and this team's own. They are providing you support. Though it is a open source framework, right? Or any open source framework, they should have support. Whoever implemented the framework, right? They will provide some extensive support in case if you want to pay to them, and if you want to get more support, or if you want to hire people from their organization, they will provide you, and they can implement applications as well, as they are expert in that. Sometimes these open sources frameworks will go to end of life also when industry found any new alternate or a best in the market frameworks, right? Slowly, if it is not viable to continue, then they may stop it. That is what happened with the Struts framework. Struts 1.x continued until 2010, 2012, 13. There they decided to end it because nobody is using after that. Because Spring became more popular, more easier, more lightweight, and why should people still need to go with Struts? So then Apache decided that let's discontinue. Since there Spring booming started, and it has a lot of features, need not to compare with any other framework. They are not even 1%, they don't even have 1% of Spring features. And continuously Spring is upgrading and adding lot of features. So it is ruling the enterprise world now. Every application is developing in Spring Boot only. It became such a strong framework. Okay. So what people will do in the frameworks means same thing whatever we have in the core Java, using the similar features only, they will create some best patterns. They will create some best patterns. By following the best patterns, they will create frameworks. So that, let's say if it is a plain application without a framework, without a framework, without framework, when you want to implement an application, as a developer, you need to put lot of efforts. As a developer, you need to put lot of efforts to make your application, to implement your application. Lot of efforts you need to put. You need to know all the best design patterns. You should be well expert in threads. You should be expert in memory management, and you should be expert in many areas. So finding a developer with all these expertises is not so easy. Finding an expert developer with all these features or with all this expertise is not so easy. And though if you have all this expertise, you know how they behave. They may continue or they may leave the company also in between. So it is very difficult without a framework. If I choose a application development, I need very skilled developer, whereas maybe I need to pay him 1 CR per annum to him, and the delivery he may able to produce one or two applications per year. But when you choose a framework, with the framework like Spring or Spring Boot, let me name it Spring Boot. So you can hire, instead of a very skilled developer, you can hire here few freshers and few seniors who know the Spring Boot or Spring Boot microservices, a junior developer and few senior developers and few technical leads. You may hire 5 to 6 team members within that budget. In 1 CR budget per annum, you will be getting 6 team members. And the productivity, coming to productivity, what they can deliver is they can deliver up to 10 to 15 applications per year. Per year, they can able to deliver 10 to 15 applications. How it became possible? Because of frameworks. They need not to have too much skills. During designing of framework itself, they followed all that, and they are asking just to follow their instructions while designing your code. While implementing controllers here, you need not to follow any particular design patterns, or for business or for DAOs. If it is in normal way of coding, he need to show a lot of skills here. But here, just continue with whatever annotations they have given. Design as per their instructions. That's it. Internally, it will follows all the best practices. Better than him, better than him, you will be designing application here, which means you are not writing the code. The framework internally adding that advanced level of features to your application on the fly. So obviously people will pick up the framework which is having the best practices, best principles, all the best threads they will follow internally, best design patterns they will follow, best memory management, etc., etc., etc. Coding they make it simple. What all they need to make it simple? Coding, testing, delivery, all these areas they made simple. In all these areas they made things very simple. Coding, testing, delivery is so easy. That's the reason. That's the reason we should pick up a best framework for designing any application. Okay. So Spring, Rod Johnson adopted the class.forName approach. Class.forName approach. Okay, that is the foundation. That is the foundation. Just a minute. He adopted that feature and he put a foundation for the Spring framework. So class.forName and runtime polymorphism approach he picked up and he started creating IOC containers. IOC containers. He designed IOC containers. How they will work, how they will perform. Simple. He also internally written the same code, like how we implemented class.forName. Let's see how many containers he given. Namely, he given three containers. Bean factory. In this framework, he given three containers. Bean factory, application context, and web application context. Web application context. These three are the IOC containers. We'll talk more about containers. Okay, we'll talk more about containers. Bean factory, application context, web application context. These all are the containers. What is the definition of a container? The definition of container is whoever manages your application classes. Whoever manages all application classes called as container. Whoever manages all the application classes, we call it as container. What do you mean by manages? What is the meaning of managing application classes? In general, again going back to old way of coding, going back to old way of coding. Here, when you implement classes without a framework, using a traditional approach, if you create somewhere, you should deploy these classes. Here, you need servers to deploy these classes. You need servers. Let's say if you use servlet technology, EJB's technologies here, servlets and EJBs if you used, he should be deploying this code. He should be deploying this code into whatever classes, right? Let's say if you write if you write 100 classes for application, 100 classes, all these 100 classes we need to, or he need to move to a server. He need to place this code into a server like JBoss or Tomcat. JBoss. Tomcat will not support EJB, but it will support servlets. WebLogic or WebSphere. There are a lot of application servers we have. So we call these servers as containers. Why? Because your servlet objects and EJB objects are created and managed by the servers only. When you use EJBs or when you use servlets, they don't use any new keyword to create these objects. These containers will create them. Just we write a servlet class, automatically Tomcat will create object. Just we write a EJB class, automatically JBoss or WebLogic WebFare will create object. So all the objects of your class will be created by these servers. That's where Rod Johnson found the problem. That's where he found the problem. As Java is a open source, I am writing the code that is perfectly fine. But after writing the code to deploy and to run, there we have a containers dependency. To create objects of our classes, definitely we need to buy a server. That is where he found the problem and he started creating containers. He started creating containers and he said, you need not use any server to run your classes. To run your classes, we have IOC containers, self container he given. Self containers he given. Just by using the self container, just by using the self container itself, you can run your classes. Which means these classes are like servers. These classes are like servers. Or I may write this statement here. Not fully alternate, but just for our understanding sake, I'll put here. Alternate to Tomcat. This is not exactly true statement, but to understand these, it will be easy to do. Okay. Alternate to Tomcat, WebLogic, WebSphere, or JBoss. All these are application servers. These all are special softwares. You need to buy license and you need to run it in your server. Yearly maintenance you need to pay. Lot of stuff. So to overcome that problem, he given open source Java library he given. Just by using this open source Java library classes itself, you can get the benefit of servers. The servers benefits you will be getting here. These classes will behave like servers. These classes behave like server scheme. Is it? Yes. So that means, are you saying that these classes will manage all your application classes? Yes. These classes will manage all your application classes. In real time, this is the container that we are using. In real time, we use this container. In real time, we use this container. In real time, we use this container, web application context. What this web application context will do when you implement a application, right? When you implement application registration form or whatever it is, any number of UI and backend classes you have. Forget about UI. Backend classes somebody should run. So all your backend classes are going to run on this web application context only. All these classes, all your backend classes objects are created by this web application context server only. But it is given in the form of simple Java class. Though it is a server, it is given to you as a simple Java class, not like a special software. They made it as simple Java class and given to you. So you should learn first how to use that Java classes. How to use that Java classes. These are the containers. The purpose of this class is container, server in other words you can say. You should learn how to use this server or containers. Bean factory, application context, web application context. This is the one in real time we use. What about other two? In evolution of framework, they started creating first Bean factory and they realized that okay, Bean factory features may not sufficient. They moved little bit advanced and created application context and later they realized okay, application context. Beyond application context, we need features. Then they brought web application context. So since beginning, we have this web application context. Using this one only in real time, we run the applications. Do we need to really write the code with this web application context in real time? Means no. By default, it will come and it will execute. You need not to apply any code. But to understand about this more internals, we will use application context and we will see how it will behave. The behavior of Containers we will understand easily. Okay, we will go through application context and the behavior we will understand how in real time it will behave. Just a minute, please. Are you clear so far? I'll unmute you guys. You can ask any questions. Yeah, you can unmute yourself if you have any questions. Okay, no questions. Good. So, yeah, once again, why we came till this context means to manage all your application classes objects. Earlier, it was so difficult while using old approach with the skilled developers. They used to invest a lot and write the code here, and that classes to run right. We need a different server environment. In Spring, they made it easy so that nowadays we all are surviving here. Instead of one skilled guy, they are hiring us, like me and you. So we are sharing the same package here. That means we are not getting very less, right? At least 5 years, Spring guy getting 30 plus in the market now. 30, 40, 50. Depends. స్వాతి సెషన్ అవ్వలేదు. Yeah. So, yeah. So he made it simple. You need not to read a lot of books and you need not to do engineering for again 4 years, 5 years to learn all this. Just we can easily learn the Spring framework within 1 2 months, and you can do better performance than him. That means you are not doing it. The framework itself is providing all that beauties to us. And firstly, we will understand the internals, how these containers will work, and we will go how it given advanced features to make our life easy. Okay. So the basically right, I'll give one statement and close this. Basically, this container's main job is the main job of this containers, as I mentioned it here, they need to manage all the objects. Apart from that, right? Here, Spring containers will do auto object creation, with the default singleton principle, dependency injection. So this is the one which is actually allowing us to achieve this runtime polymorphism more easily. Dependency injection, auto wiring. They made dependency injection again simple. Dependency injection means DI. They made this dependency injection itself again easy. Easy means they made it zero code actually with auto wiring. One by one, we will go to very advanced features. And next, no configurations, no configurations in XML. Earlier we used to configure in XML. They given stereotypes feature to reduce the configurations. By the time we reach here, our life will become simple. Initially, when we see few classes, we will see okay, a lot of configurations I'm doing. They are not really lot, but few configurations we do. But by the time when we reach here, we realize that okay, this is simple. Nothing I am doing. Everything Spring is doing. We will go such a advanced level. Okay. Apart from this, there are other features like life cycles, event management, but I don't want to confuse with all that words now. Okay. We will understand the basics. Very strong basics we need across all these four topics. Okay. Very strong basics. Then we will see all the other miscellaneous topics. Okay. Yeah. So tomorrow we'll continue that. Okay.